Hello everyone. Let me see about the topic of image compression techniques. What are the starting stage problems which are to be occurred in the image processing? We can take in as a compression technique levels, how it happened to consider the image of why we recovering the constructed image. Let me see the image compression techniques. Welcome to all. This is the introduction of an image compression. Why we are using image compression techniques? By reducing the size of an image in bits of an image without degrading the quality of pixels present in images to an unappreciable level. For example, we take an image by using the original image while we converting. For example, we transferring the image from one device to another device like mobile, like these things which are to be transferred from one device to another device. The original image will not destroy. For example, the original image we send to another image, we getting the image is an exact image, but the original data and the retrieve data is to be different by using the pixel values. For example, we send one image, we can capture an image is 4 by MB like megabytes, and also transferred to a data, and we see it's a shown as KB ratio. For example, how it happens, the same kind of image is transferred from one device to another device, the compression ratio level to be detected. While we transferring the image by using the resize, it can be resized when it produce the storage space of that other files. This is the original condition of the format by using the compression techniques. Here we discussed a new approach for an image compression, while the multi-layer wavelets is to be used by using dual tree complex wavelet transform with wave multi-layer that preserve the dominant brightness level and intensity of the target image in layers, with the results to be transformed in the layered wavelet coefficient close to 0. For example, how we determine the wavelet coefficient level into the dominant brightness level and the intensity of the target image in layers. So for example, let me see the layers. What are the layers to be considered in an image? For example, in image processing technique, we have image pre-processing, image enhancement, image segmentation, the feature extraction, and the image classification. These are the techniques which are to be overruling the image processing technique, and it is differ towards the compression technique. Here we see one image is considered as an multi-layer wavelet format, and also using towards the compensation of the image. For example, we see the image we getting the threshold frequency level of an higher ratio to lower ratio. How we can get the image by using the wavelet transformation. For example, we send an image for one dark image, we put one torch light. For example, the center place we get an one brightness of an image. This is a wavelet formation. Here we see the graphical formation. This is a basic notation. We have to be conclude the image by using the wavelet transformation. The wavelet is nothing but we can see the wave format. Is also consider the image by using the higher compression ratio and the lower compression ratio. How we getting means the threshold frequency level of an image while we comparing to the original image. Here this is the starting stage of let me see the different kinds of texture image concepts to be maybe clearly we get the exact result. The wavelet analysis needs additional support for the compressing the data by using the Huffman coding is used along with the wavelet analysis of an image in order to compress the data. We can use the original data. For example, original data is nothing but an image while we transferring to device, or like why we transferring the device. For example, we have 1 GB information, we have to be transferred to another GB, means the same data will be get in image format. We can lot and lots of images are there, we can transfer and store the image. It's a huge process, so we can exact the compressed ratio of an image. With the compressed image to be showed, that we get the exact results. And finally the best result with higher PSNR. PSNR is nothing but peak signal noise ratio, and the compression ratio and minimum is mean square error is nothing but MSE in compare is to be compared everywhere by using the PSNR is the MSMR is major ruling the image processing techniques. While we see here how the image will be transferring and to be compression. For example, the original image is said to be a raw image of a data is to be transformed. How it transformed first for processes color transformation, and the sampling method is to a couple of sampling, upsampling, downsampling, and the forward discrete cosine transformation is nothing but DCT, and the quantization process is nothing but by splitting the image by varying the equal parts of the methods. And also the method is said to be encoding. The transformation is occurred, last stage is encoding, and the JPEG compressed data is to be compressed. And also we get an original image by using the reverse process of an decompression level. By using the JPEG compressed image is considered as a decoding format, and also the quantization is occurred reverse is dequantization process. The forward discrete cosine transform is considered reverse cosine transform, and the downsampling is considered upsampling. The same color process will occur, and the original data image we get. This is JPEG compression, and the JPEG decompression process is a cyclic process while we getting a original image and compressed to a JPEG image. While I hope you clearly understand this concept. And also see, image compression techniques are mostly classified into two types. One is lossless technique, and the another one is lossy technique. These are the technique which are to be majorly overruling the compression technique. We have easily identify what are the techniques which majorly ruling the compression levels of them process. While we getting an image by using sensor nodes which are to be wirelessly connected to the device and retrieve an image by using some kind of traffic rules by getting a designation sequence distance vector routing protocols. That is nothing but DSDV protocol is to be used by using a sensor nodes to get an image while we transmitting to a image data. And the lossless compression technique, I hope the original image we can usually find out what are the techniques which are to be available in the compression levels before you see the slide of an image. And you see the lossless compression technique. The lossless compression technique, the original image can be absolutely recovered from the compressed image. Compressed means this nothing but encoded the original value of an image while to be reconstructed to be a compressed format, and also known as noiseless because they don't add any noise to the signal of an original image. And it also entropy coding because it uses decomposition technique to eliminate or minimize the redundancy level of an image while we getting towards the original image of an raw image. And the lossless compression is used to simplify for a few applications with strict requirements as a medical image. Medical image we can see everything, X-ray, CT, MRI, like these kind of things to be considered by a grayscale level. These are the things starting stage we can see one by one process of the we getting a medical image process. We can see lots and lots of things are to be available in the compression techniques. It is much more useful for us the previous concept. Lossless compression technique, what are the techniques which are to be used? Run length coding, Huffman coding, LZW coding is nothing but an image of an constructed image. And while we reconstructing the LZW length wig wealth is a name of the coding is used. And also area coding is the difference between while we getting the collection of data to be transferred while using the image format. The implementation of an JPEG compression for images is typically carried out in raw binary files. Binary files of an image is transmitted to zeros and ones. By using a MATLAB or like these conditions, you can easily classify how the binary images to be reconstructed by using the constructed filter format and the intensity of an pixel level. The pixel level you can be easily mentioned how it happens, like these things we easily find out what are the techniques to be overruled. And the image is splitting into like one image we can take, it's splitted into 4 blocks, and we see the one block is higher level, another block is lower level. This is one image is split into 4 types I said, and the 4 types we can see is for 2 square format, and also the one image is constructed to 2 format is nothing but one image is divided into 2 types, and the second image is nothing but lower order and the higher order, and we get the resolution of an image while we transferring upper level and lower level, and we see the intensity of the lower compression ratio, higher compression ratio. The block level of the pixel is serially feed into the image compression device is a raster order. It's nothing but the split of blocks is nothing but 8 into 8 pixel format. The lossy compression, another format, is used for the technique which are to be higher compression ratio than lossless compression. In this method, the compression ratio is high. The decompressed image is not exactly identical of the original image, but close to it. It can be easily mentioned how the original image and how we get the reconstructed and image by using the lossless compression. In the format we can easily identify. The different types of lossless compression techniques are extensively used, characterized by the enhance of the reconstructed image, and it's sufficiently for application while we using the object detection, object switching, 3D modeling, and the gesture format. These are the texture which are to be used in the image processing techniques, and the quantization process is applied in the lossy compression technique results in loss of information. We cannot lose any kind of information by using the lossy compression techniques in an original image. After quantization, the entropy coding is done like lossless compression. The decoding is a reverse process. While we see the image, the JPEG compression is occurred to the transmit level, and the another is decomposition level to be reverse process by using the decoding process of an reverse process. The entropy decoding is applied to compressed data to get the quantized data of an image. By dequantization is applied to it, and is lastly the reverse transformation is performed to obtain the reconstructed image. The methods that fall under lossy compression methods, which are to be lose any kind of data or any kind of information by using the pixel values, like and all, by we do not transmit that kind of energy efficiency by using the compression level, is to be ruled in the lossy compression technique. For example, here we see we construct an easy format. How you can understand easily how the original image we can predict what kind of image like this, like these things we are using, and the transformation occur, and the image decomposition is to be considered, and the process is to conclude the entropy of an lossless coding. After quantization process, the image will be quantized into splitting as we said, the higher compression ratio and the lower compression ratio. These are the techniques into splitting into blocks method by using quantization, and the process is we get the compressed data of an image. You see the original image, we can predict the image transformation and the decomposition. The three techniques which are to be used in any one of the format, and also encode, lossless encode, the format is to be used. This process is quantized is nothing but concentration process, splitting the higher compression ratio and the lower compression ratio and into the blocks of a pixel of image, while we transformed to compression data of an image. The lossy compression we said before, no, and the techniques which are to be used: transformation coding, vector quantization coding, fractional coding, block truncation coding, subband coding. These are the techniques which are to be used in the compression levels. By using lossless compression and the lossy compression, these are the coding techniques which are to be implemented while getting the exact results of an image. And also the two levels of wavelet decomposition are used since all even positioned image pixels are decomposed into low pass coefficient, and the hard positioned image pixels are decomposed into high pass coefficient. The total computational energy is involved in horizontal decomposition. Here usually you can identify is even positioned images are low pass coefficient, hard positioned images high pass coefficient. These are all we classified in the total computational energy and gets the result in an horizontal decomposition level of an process in the lossless compression techniques. And you see the advantages and disadvantages of decompression technique. Here you see SIFT, scale invariant future transform, is used for the stability, accuracy and reliability process is to be main advantages. The main disadvantage of the SIFT process is key localization process. Here the technique is used for the application, object detection, gesture, image switching, 3D modeling. These are the technique which are to be used, and it is used for detect and describe the local features of an images by using the SIFT process. And also PCA is nothing but an principal component analysis, and also DCT is nothing but discrete cosine transform. It is very efficient and faster to compute, is used for face recognition technique. And also disadvantage is noise increases. And also you see RBF is nothing but radical basis function used for the restoration of an damaged images. It's free from local minima. Advantage is very slow, the process to be very slow. FFT is nothing but fast Fourier transform, is less encoding decoding time, and also server block effect will as a main disadvantages of the FFT process. ETC process is nothing but Ericsson texture compression. In this format is used in the Android 2.2 Frozio is support before the Android compression technique, and it's used for the lossy texture compression is used for the ETC method. And also it is a high level security, less efficient in compression. This is the main disadvantages of the ETC process. BZW is nothing but based on the embedded zero tree wavelet. It is also main use of the lossy technique. It is used for the high pulse spectral images, and the disadvantages is too more costly. And we see here the advantage and disadvantage of the process of an compression technique. What we are the results it's to be followed. Before and all, we see the performance matrices of an wavelet is to be calculated by using the peak signal ratio and the mean square error ratio format, while we using the PSNR is to measure the peak error between the compressed image and the original image. This is a main process. We can easily find out how the error is occurred from the original image and we get the compressed image. Here we can easily predict where the measurement to be occur in the original image. The parameters are used to measure the performance of the image compression algorithms is nothing but a peak signal noise ratio and the mean square error. The main concept is used to detect the error format, the wavelet analysis. Before and all, we see the wave format is an up and down processor. Here you easily find the where we get the images to be destroyed and the images where to deploy the error to be considered. The higher the ratio is to be enhanced the quality of an image is to be content. To calculate the PSNR, first of all the mean square is also computed. These and all main things which are to be used. The mean square error is the cumulative difference between the compressed image and the original image. We can easily predict the image error format and also the techniques which are to be used. The small amount of mean square error reduce the error and improves the image quality by using the performance matrices. And also the uses of an proportional reduce the number of arithmetic operations on memory access to be overcome the image compression technique. And with the major rule of these processes, elimination high pass filtering is nothing but EHPF concept of elimination high pass filtering. Here we using the technique is mentioned here, the proposal of the arithmetic operations. These are the basic notation of the PSNR is nothing but PSNR equal to 20 log 10 to 255 by square root of mean square error, and the mean square error is nothing but 1 by mn summation y equal to 1 to m summation x equal to 1 to n I of x comma y minus I dash of x comma y whole square is the mean square error. Basic format is to be mentioned. These are the calculation of the image compression technique is mainly used for the two techniques. And here you see this is an hyperspectral image. We get the image from or through the satellite of an image. Here you easily predict what are the techniques which are to be used here. Here you easily predict the wavelength of the concept is to be overcome, of the result is to be mentioned, and also how the technique is elaborate towards the concept is to measure the concept. For example, the water is to be said to be a pure pixel. We can easily predict how the pixel value of an image is likely determined as pure pixel of an image. And also you see the mixtured pixel is nothing but vegetation plus soil, is nothing but a tree oriented places like is contained within soil format. And also the mixed pixel, one more, is soil plus rocks. These are to overcome the pixel. This and all we give some values on the wavelet format. We can easily predict the wavelet methods, how it can happen, like the tree is too tall, the mountain is too enhanced, and these are the technique by using the hyperspectral image. And we can also filtering the image by using so many techniques are there. Now we seeing the basic concepts and we using some techniques to be related with the hyperspectral images. Here you see the input hyperspectral images are to be PC calculation. The so many features which are to be enhanced, the layers of an image we taken, so many data of an image is taken, and we exact the Gabor feature extraction is used for this feature. And also the Gabor feature is collection of data of an hyperspectral image. The two combination for further how we can classify these techniques, the future concatenation of an image by using an combined data of an Gabor feature extraction technique, which can to be concatenation of the image is to overcome the classification of kernel based machine learning machine. This the technique is mainly used. Kernel extreme learning machine is used for the prediction of a process, and we get the input hyperspectral images into MH prediction process. The spectral spatial integrated data of an image is overcome to the classification of the KERM process. These are the main thing which are to be easily we can predict their data. How, why, the purpose we can using the compression technique here. The lots and lots of images to be getting from this satellite, we can easily combine towards the technique of an Gabor feature extraction, the future concatenation process. These are the technique which are to be classified by using the claim process. And also we are in the conclusion level process. This we easily predict by the given input of an image. You can easily predict, and you can also work it out through the image process. And these are the techniques which are to be used in the multimedia image compression. One of the tasks for reducing or compressing the developed various techniques are to be followed. In some of the technique is described and it's not good, and the future compression size of an image data, while some images to be considered as a blurry image is formed in the future, determine such method which compress accordingly, and image must be clear. We can easily predict the how the image is will not get affecting the noise of an image. Also a breakdown of the starting stage of an image and the closing stage of an image, the density of nodes in the stored network. These are the main concepts which are to be stored image. We can easily predict where we get and where to use, and like these things which are to be overcome for the images. The images which are to be stored by transferring the data of an image by using the compression techniques are obviously useful. Before it all we see lots and lots of image. Why we taken is the satellite will send the images and we can store it as lots and lots of images of data. So only we can easily store the device, we can compress the data, and we can store the data of images. This work offers much flexibility at different process level. We have focused the design and evaluation of an efficient image processing depending on the operating parameters at different process level, which are to be mentioned higher compression ratio and the lower compression ratio, where we can predict means the ratio between the graph. For using the wavelet formation, the wavelet analysis is used for the numerical analysis and the functional analysis. We can easily predict by overcoming the result of an image processor. By using these kind of techniques is much more predictable for the compression techniques, is to be useful, is to be helpful for everyone for using the image processing. And any comments means you can easily ask me. It's a time to validate for us. I hope you and all easily predict the image compression technique by using the image processing concept. Thank you one and all.